This class we will discuss about ground improvement techniques. This is a photograph showing how they do the Vibro-Compaction. So what is ground improvement? Ground improvement means enhancement of the in place properties of the ground by controlled application of technique suited to the subsoil condition. Depending upon the type of soil, there are different methods available which is listed here. We have to do that to increase the soil properties. Why this is required? If we do not increase the soil properties, there are many disadvantages. I will explain about them. One of them is the cost. If we improve the soil properties, the cost of the foundation will be much less compared to without improving the soil properties. Sometimes if we do not improve the soil property and do the construction, there is likely to be failure, not only for the foundation but also to the superstructure. There are basically 4 methods. One is the soil densification, that is you improve the density of the soil. Another is pre-consolidation, that means you do the preloading, so the consolidation takes place. Then injection and grouting, that means you use some chemicals for grouting. Next is soil improvement, either by geo grids or geo textile reinforcement. So each one has its own applications. We will discuss some of them which are being used for marine structures. So we have weak deposit. The weak deposits are in coastal areas, and one of the weak deposit is the soft marine clay. It flows like liquid. This type of structures are there in Vizag, Cochin and Kandla. One of the structure which was built recently has collapsed because they did not take into account either improving the soil, soft marine clay, or they have not designed the structure taking the correct properties of soft marine clay. In Kandla, during the Bhuj earthquake, there was some failure means not complete, partial failure to some of the piles because of the earthquake induced slope instability. Cochin also we have very soft marine clay. Here the depth of the soft marine clay deposit is more than 60 meters. 60 meters mean 20-story building. So they have to go for piles. When they put the piles, you have to go at least 60 meter below the seabed or below the ground level in the land. One of the problem of the soft marine clay is it will have what is known as negative skin friction. Instead of the pile taking the load from the substructure, because of the settlement of the soil more than the settlement of the pile will take additional loads, that is called as negative skin friction. That means the total capacity will come down. Then we will have loose beach sand, then we have alluvial deposits, these are on land. Then there are some low lying areas which will get submerged by flood or tide. So when this happens also, the weak deposit further weakens whenever there is submergence of this deposit by soil. The soft marine clay, the moisture content is very close to liquid limit and the cohesion strength is 10 to 20 kilopascal. So this is very low value. The SPTN value will be between 0 to 2 or less than 2. So when they do the SPT test, where they put where they find out number of blows for penetration of the spoon, you do not need any number of blows, it will go on its own sulfate, that is defined by this soft clay. Void ratio, compression index and coefficient of consolidation is given here. These are used to calculate the settlement, which is beyond the scope of this present lecture, but these informations are required if you want to calculate the settlement. So what is the problems with soft clay? It has very low bearing capacity, maybe normally the bearing capacity very low value is about 5 tons per meter square, 50 kilonewton per meter square. If it is a very good soil, it will go up to 40 tons per meter square, that is 400 kilonewton per meter square, whereas very low bearing capacity means it will be about 5 kilonewton per meter square only, very low. There will be large settlements, this I indicated in the last class. the total settlement and differential settlement. Total means if there is a structure, how much will be the total settlement, but there are two points in the foundation, two ends, they will not settle same way, there will be some differential settlement. Differential settlement permissible level is very low, and some of the soft clay deposits where we want to build breakwater, example is recently we are designing settlement for a breakwater at Parangipettai, which is near Chidambaram, for a infrastructure project for a power plant. The settlement is about 3 meters. Once you put a breakwater stone, if you do not treat the soft clay, then the settlement is coming about 3 meters at the where the height of the breakwater is high, at other ends it will be less, about half a meter. That means the total settlement is about 3 meters and the differential settlement is about 2.5 meters. This settlement is a long term settlement, the settlement will not be immediate, it will take years, years means 10 years, 20 years to achieve the settlement. The maximum settlement what we are calculating, about 90% will be reached in about 10 years time, whereas the balance will take another 10 years. There will be negative skin friction on piles, and these piles will also have low horizontal load capacity. There will be instability of deep excavation slopes, whenever you excavate there will be instability. Then there will be high earth pressures on retaining structures, then there will be lateral flow under surface loading. These are the various points to be discussed about load bearing capacity related to soft clay deposit. Did we discuss about breakwater design? Then we discussed about Hudson's formula and other things. All these things are based on waves, how much wave absorption is required to resist the wave, what should be the weight of the stone. There is no soil property coming into picture, right. So what happens is, if I will draw only the outer boundary of this breakwater, this is your water level. We calculate the armor units and other things based on the wave height and wave period. We have never discussed anything about the subsoil. The subsoil is dense sand or rock, there is no problem. Suppose there is a soft clay deposit here, bottom, what happens is whatever material you are putting, this material makes this, suppose this is a soft clay layer, this soft clay layer because of the weight, suppose let us say we are putting it for about 10 meter, because 10 meter means the weight will be about 10 into density of rock. Density of rock with armor units is 10 into, let us say about 2.65 into 1 minus 0.3. The 0.3 is the void ratio. Whenever you put the stones, there will be some openings. Suppose you take 1 meter by 1 meter box and you put the stones, you cannot pack it like water. If you put the water, 1 meter by 1 meter by 1 meter will have a volume of 1 cubic meter, whereas when you pack it with stones, the volume will be only 0.7 cubic meter. That is what it is given as 1 minus 0.3. 0.3 is the void ratio. So this will be the weight. So the weight will be approximately, if you calculate, $17.55 tons per meter square. So about 10 meter height will give you a value of 17.55 tons per meter square. Some of the soft clay deposit, the bearing capacity can be much less than 5 tons per meter square. This is the lowest value, but some of the soft clays may have only 1/10 of that. So if you put where the capacity is 5 tons per meter square, if you put 17.55 tons per meter square, what will happen? What will happen? What is it? Cannot withstand. What will happen? I am asking. It settles. What happens to the clay? Huh? Consolidation will not take place, it will be squeezed out. So if you put this on top of this soft clay deposit, all this soft clay will go to the sides or go to the forward end, it will not remain there, it will be called as a mud flow. That is what is given in the last point, lateral flow under surface loading. Suppose the last point is given in this power point, when you put the loading the lateral flow will take place. So here the intensity of pressure will be high, here the intensity will be less. Suppose let us say here, actually what we have to do is, in this type of situations we have to put what is known as a toe berm, so that this toe berm is required. So this will avoid the slope instability problem also, there will be a slope failure, the whole thing may collapse also. Suppose you do not put the toe berm on either side, what will happen is whatever stone we are putting, the whole thing will collapse. See, there are two things that will happen, one thing is the soft clay will get squeezed out, the stone will go inside, this is the place where the stone will go inside. Other thing is whatever you are going on putting, it will get collapsed. You know this quicksand condition, so there are some places near Kodiyakkarai in Tamil Nadu and some other places where deers know where this quicksand is available, human beings do not know. So if you are going there, if you step into that, you will get inside nobody can save you. There are certain patches where there are certain wetlands which are having some quicksand condition, it is not you cannot, humans will not be able to recognize it properly, you cannot walk just like that, if you get into that you are getting buried into the quicksand condition. Like that only here also the whole thing will collapse, and sometimes you may not be able to build the breakwater. So the slope also will be unstable, so there will be some slope failure which will take place, and to avoid the slope failure we can have the toe berms, that means you are increasing the width of the foundation, the whole thing also will get, so you will have some kind of pressure distribution. So here only you will have the upward pressure to resist the soil, you got the point, no, the area is increased to take the foundation, this is what we have to do. But in some of the cases what we are doing is, we do not treat the soil, if it becomes very expensive we calculate the settlement may be about 3 meters here, settlement may be about 0.5 meter here, the differential settlement is about 2.5 meters, total settlement is about 3 meters. This total settlement also, this immediate settlement about 70% or 60% of 3 meters is expected maybe in about 3 months or 2 months, 80% of 3 meter will take 10 years, 100% of 3 meter will take about 100 years also, or maybe about 25 years, 99% I will tell. So it takes years to achieve the settlement. So what happens if the settlement is more and more is increasing, the top surface is uniform, so it will get, there will be undulation, the settlement also will not be uniform along the length as well as along the width, it is to be avoided. Then we have written anything, something about negative skin friction. Anybody knows about negative skin friction? Suppose you drive a pile, so this is your original soil, original ground level, this is your formed ground level, here only you have the load coming from maybe storage tanks, Cochin and other places we have the LNG terminals where they have a large tanks may be of even 80 meter in diameter, maybe 20 meter in height, very huge tanks supported on piles. Okay, this was the original ground level. You increase the ground level to form the ground level. Let us say original ground level is, let us say, about plus 1.0, formed ground level is about 3.0. That means there will be a loading on the existing soil. Let us say that this is soft clay, this is stiff clay. So, will the pile have settlement? Yes or no? When you load the pile, will the pile settle? Yes or no? Yes. What about this soil? Will it settle or not settle?
Yes.
Why it settles? Why the soil settles? Why does the soil settle? Because we have put this overburden pressure. Originally this load is not there, now this load is there. So which settlement will be more?
Soil.
So if the soil settlement is more than the pile settlement, then there will be, this will be dragging the pile down. This is called as negative skin friction. Is it clear to you? Soft soil will settle more than the pile, that means it will drag it. How many of you have seen any temple festival? Have gone to any temple festivals? Huh? No, you are not answering anything here. Which temple you have gone? You raised your hand, na?
Yes, sir.
Which temple? Behind that fellow. Which temple you? Huh?
Kerala.
Kerala, which temple?
Guruvayur.
Guruvayur. Okay. Will they take procession of the idols? Will they take the idol around the temple?
Yes.
I do not know. Which temple you have gone?
Sir,
Why you can tell the temple, yeah. Asking something secret.
nearby my hometown.
Which one?
Nearby my hometown.
What is your hometown?
Salem.
Salem. What temple it is?
Sir, Kotai Mariamman.
Will they take the idol around? Yes. Okay. Nobody has gone to Mylapore temple. Huh? How many of you have gone to Mylapore temple? Which month?
2 months back, sir.
This month you didn't go?
No, sir.
Why? What is so special this month?
Sir.
Huh?
Sir.
How many fellows are from Andhra? Yeah? Raise your hand. Only this many. Why you people can go to this Mylapore temple? Yeah? This month there is a festival. You know that or you don't know?
Sir, you know, sir.
Huh? Where are you from? Shivagam Sundari? Jayangondam. You have not been to Chidambaram?
Yeah, I have.
You have been. You didn't go during temple festival. See what happens is during temple festival, there is an idol. Idol will be kept on top of some chariot and people will be lifting. The idol weight will not be more than 100 kg. How many people are required to lift the idol? 4 people will be sufficient. But how many people will be lifting? At least 40 people will be lifting. Actually only 4 people only will lift. The other 36 people will add load onto the other 4 people. That is called as negative drag. If you go and see the temple festival, so many fellows will go forward to lift the temple idol. There will be some higher sitting on the top of that chariot and all, but his weight will not be more than 60-70 kg. But instead of 4 people, 40 people will be lifting. But out of that 40 people, at least 10 people will not be actually taking the load. They will be loading onto the other people also, because they will be hanging onto the chariot. That is what will happen. Then this low horizontal load capacity of the pile, because when you put a pile, the soft clay will not take any load. Then instability of deep excavation slopes. So this instability, suppose this is a soft clay deposit. So if you excavate, like this for a berthing structure, you can have various slopes like this. So this is vertical cut. This is possible if it is a weak rock or rock, you can cut vertically, the slope will be stable. Then we can have a slope like this, one vertical to one horizontal or 1.5 horizontal. So if you dump some stones and form the slope, you can have, or if you put some geotextile material, you can have this slope. Normally this slope is recommended 1 in 3, 1 vertical to 3 horizontal in this region, but it can go to 1 in 5 also, okay. But now suppose you put some surcharge load on this, you stack the container, then the slope may fail. If suppose you have excavated like this, the slope will fail, and that failure is to be avoided because of this surcharge load. Another thing is, when you have this seismic condition, the soil which is being retained in the slope, that also will give an acceleration, due to that also it may fail. So this is one aspect which is to be considered. And suppose you put a retaining structure here, you want to have a vertical face and put a retaining structure here, this retaining structure also will be subjected to heavy horizontal forces, right. This for a soft clay, the value is Ka gamma h minus 2c. The C value can be very close to 0, right. When the C value is very close to 0, it is Ka into gamma into h. Gamma is the density of soil. So it will be retaining a liquid mud, there will not be any C, so that earth pressure also will be very high. So these are the problems related to soft clay layer. So you have to take all these things into account while designing the structure. So this lecture is not restricted only to the ground improvement, but also the design aspects when you do that. So the properties of loose sand is given here, the N value will be 4 to 10, the angle of internal friction is between 28 to 30 degrees, this is the compressibility modulus and permeability coefficient, these are used to calculate the settlement. I said for stone the void ratio is 0.3, whereas for loose sand it can be very high, 0.75 to 0.85. So I have not given this properties of silt here. Between clay and sand we have silt. Silt also will liquefy during seismic condition. So if the silt is there, especially if you have atomic power plant and all, if you have a silt or loose sand, the value is less than 10, you have to necessarily do the ground improvement, then only you should put the foundation, because statically you may be able to satisfy the design, but dynamically during seismic condition it will become a quicksand, whatever you are doing the whole thing will go down. After the this tsunami, I think it has happened in 2004, I think, no, 2004, there was an earthquake and tsunami together in Port Blair. There was one structure which was built, the whole structure has gone down. There is a jetty more than 300 meter length, it has gone down by about 30 meter, it has not gone down up to the seabed, it has gone down much below that also. So much of liquefaction has taken place, the whole structure from the top it has totally gone down. So these are similar problems with loose sand, low bearing capacity, higher settlements, susceptibility to liquefaction. Then we need a temporary support when you want to do a excavation. Suppose you want to do a excavation, then you have to provide temporary support, then there will be very high seepage also, and there will be large earth pressure on retaining structures because of low angle of internal friction value. So this figure shows what is a shallow foundation, what is a deep foundation. So if we have a weak soil, then you have a dense soil, then we have to necessarily go in for a deep foundation which is called as a pile foundation, you go into the deeper soil. This is possible even if you have a weak deposit, maybe 3 meter or 4 meter or even 6-7 meter, you can take it deeper. I have shown in the figure also where we are taking the pile, you have to take care of the negative skin friction in this region, plus you have to take sufficient embedment depth so that you can get the reaction. Suppose you do not want to do that, if you want to have a shallow foundation itself, what you should do is you should compact the ground below the foundation, what you are going to do, and increase the properties of the soil. So if the N value is about 4 to 10, it can be increased to 15 to 20 if you do the ground improvement, so that the bearing capacity can be increased. So your bearing pressure will be much less than the capacity of the compacted ground. Suppose you are putting a breakwater here, you cannot put a pile foundation for a breakwater, it will be very expensive. So in such a case it is better to improve the foundation, allow the extra stones to be filled, that also is a possibility. When you dump it, the soil will flow and the stones will go down, then allow for the settlement to take place. These are the various methods that are given here. We have talked about sand, silt and clay. Here we have shown the particle size starting from 0.001 mm to 0.0001 mm, this is the clay. Silt is from here to somewhere here to here, that is silt, and sand is here up to this. So the jet grouting is a method which can be adopted for whole range of sand, silt and clay. We are recently recommending this jet grouting for berth number 1 to 6 at Kandla to improve the soil property. Then we can have soil mixing, that is also possible, and dynamic deep compaction, or we can have compaction grouting also, then we can have chemical grouting also, then we do blasting also, control blasting to improve the capacity, or we can do Vibro-Compaction. These are the various methods, some of the methods we will explain. So one is called as the replacement method, that means you replace the soil. If it is a very loose sand, you can dynamically compact and replace with a dense sand. Then we can put vertical drain. Vertical drain is nothing but this soil we provide some drains called as PV drains, and here you put sand as a filter layer. So actually this whatever you are doing here is called as a preloading. It is typically done about 6 meter to 10 meter. So this PV drain is nothing but plus this geotextile member, it is about 100 mm in size, it will be like this rectangular size 100 mm, maybe this gap may be about 10 millimeters, this will be 100 millimeters. You punch it through this, then you do the preloading, then what happens is whatever liquid is there, that is water is there, it will get into this and it will come right up to the top, then this will be draining to both the regions, then we will have consolidation. We have two components called as consolidation and that is also that is not settlement, the consolidation is for clay layers, it takes a very long period for the soil to consolidate. So to accelerate the consolidation, the preloading is to be done maybe for 1 year or so. So you preload the soil, is it clear to you? You put some like Netlon mesh, what you are saying, no, that you insert it, it's about 110 millimeter, 100 millimeter by 10 millimeter, it's a very small size like a paper, it goes inside, there is nothing inside, just it goes in, it's like a filter, like coffee filter only, just goes inside, then you preload it, you have to do it with preloading. So what happens is the water will get inside, and then this water will come out. Once see, there should be a place for the water to come out of the soil, we are accelerating that. This will be done in a square pattern, maybe 2 meter by 2 meter grid, you do this. This is the most economical method of increasing the bearing capacity of the soil or improving the ground treatment. This is done for many places, it is not very expensive also. For C condition it is very difficult to do, but we do some other method that I will tell you. So this is the method which is used for field condition, vibro-compaction or vibro-filtration. This is for compacting sand deposits both on land as well as underwater. Jet grouting also can be done underwater. These techniques are efficient and installation takes place very fast. One of the main requirement for this vibro-compaction is that it can be done very fast. This is very cost effective and we can have an average of 50% saving, very high saving as compared to a pile solution. So this vibro-compaction can be done in sand and gravel and stone, whereas vibro replacement, there are two methods are there, one is vibro replacement, another is vibro-compaction. This is most commonly used method in marine condition underwater. So here you are seeing, so you have like a pile driving equipment, what you do is you drive it and there is a bottom opening, you see here this is a steel casing with a bottom opening. So there is a attachment to this to the top, once you drive it to a particular level you just release the hook which is attaching the bottom plate. Once you release the hook the bottom plate will come out, then whatever sand you are filling inside it will remain there and you remove the top casing. Is it clear? So you can see the figure here, some other methods in which the bottom opening is not like that, bottom opening is like this and then you lower it, then put the sand, you can have the sand here. So once you lower this and put the sand and remove it, then you will have vibro replacement, that is this clay at a, maybe also if the diameter is the vibro compaction piles, you can have let us say diameter of the pile varying from 600 to 1000 millimeters, 600 maybe 700 I will put, 500 to 700, it is not very big diameter. So you just lower the casing pipe, the bottom opening, once you drive all these things at very close spacing, normally it is 3 times the diameter or 2 to 3 times the diameter spacing, and you replace the soil in that location by dense sand. So it acts like a filter medium also, like this, the sand itself will act like a filter medium and it is replacing the existing soil and it is compacting also. So the volume of replacement may be about 10 to 15% existing soil. We can also use what is known as stone column. In stone column what you do is, you suppose there is a soft clay deposit here, what you do is you drive one steel casing pipe and you fill it with stones, it slightly go below the soft clay deposit, fill it with stone and replace the casing. See here what you are doing is you are removing the soil by replacing the soil by stone. So vibro replacement can be either with sand or with large size stones. This also can be done to improve the property. Vibro compaction is you just put some kind of a pile and then do not replace it, you do some vibration so that the soil will get the ground will get improved. These are the various methods by which you will be able to improve the properties of the soil. So many cases we may have to resort to this type of method, that is as I shown here, vibro compaction. Blasting means is we do some controlled blasting, we drill a hole, put some explosives and then blast it so that the soil get improved. Normally after every earthquake you may have quicksand conditions, sometimes the soil also will get improved. The vibro compaction also can be done using some large weight, using a crane you lift the weight and then drop it from a height on the surface itself, so that the vibro compaction takes place. Chemical grouting means you may use lime or cement for grouting. This is compaction grouting and dynamic deep compaction. Then soil mixing means you mix the soil with some grout. Jet grouting means we inject cement and then here the replacement is about 4% or so. You do that so that the soil will get improved. There are special methods that are available, special machines that are available to do the jet grouting. So if you see some of the internet, if you go and put jet grouting, there are some companies like Keller, Bhumi, those people are having the special equipments to do the jet grouting. One of the advantage of this jet grouting is it can be used for any type of soil, whereas this Vibro-Compaction Blasting can be used only for sandy soil, it cannot be used for clayey soil, and the soil mixing is not possible for certain dense sand deposits. Okay, we will see tomorrow in our department.